Hey guys, welcome to my channel. Today's discussion about the mistakes of TIG welding. So this is a very important subject about the mistakes of TIG welding, and TIG welding is the very critical process. Everybody knows this one, and we have to discuss today about the mistake. What type of mistake can be happen, and we can prevent these mistakes. So gas tungsten arc welding. So we can tell the tungsten arc welding called as a GTAW, also known as TIG. So gas tungsten arc welding, we can use this one also, TIG, tungsten inert gas welding. That inert gas is maybe argon, maybe helium. So GTW is also known as TIG welding, is arguably the most difficult process to learn. This is the very most difficult process to learn because of the so many important important characteristic are there, and you have to control that characteristic to prevent the defect. This article contains description of common TIG mistakes and basic tips on how to prevent these errors from happening. So we need to learn today what type of mistake is there and how to prevent the mistake. What are the troubleshoot problem? So mistake one is how the poor gas coverage leads to contamination. This is means the gas coverage means maybe gas supply is not there. If it is gas supply maybe high or low, maybe flow rate is not flow rate is not the correct as per what you maintain. It should be as per WPS. So these things we need to discuss now. What are the mistakes for poor gas coverage leads to contamination? Now, poor gas coverage leads to contamination. You see, throughout this discussion, please refer to the application photo. So you have to discussion in this discussion. We have to refer that photo. That's the figure one. So weld contamination can occur when shielding gas is not turned on. So weld contamination can occur the shielding gas turn on. It's maybe turned on, but sometimes maybe too low or too high, or this is the blown away. Okay. So what do you mean by too long, too little, too much? Because in the shielding gas there is a flow rate is there, and you have to flow rate. You have to do as per the flow rate what you mentioned the WPS. So flow rate should be as per WPS. It should not be too little or should not be too much, and it should gas should be coming to the correct area, means the joint area. It should not be blown away. To troubleshoot gas contamination issues, how to check the gas cylinder level to make sure you are using the right type of gas is very important. So you are using the right type. What is the right type of gas? If it is TIG welding, generally 100% argon we are using. If it is aluminium, then you have to use the argon or helium mix. So we have to check when you are doing the welding, before TIG welding, the gas level, cylinder level, to make sure that using the right type of gas we are using. Second is the set the proper gas flow rate. So I told the first one, first already to the flow rate. Flow rate always you have to mention the as per WPS whatever the flow rate is there, we have to maintain that flow rate. If there is a flow rate is there, then excessive gas flow creates the turbulence and swirling current that pull in airborne contaminants. So excessive turbulence, what will happen? That pull the airborne contaminant. If airborne contaminants will be there, that cause arc wandering, not enough provide poor coverage of the world. So there is not enough provide poor coverage of the world. Coverage, there is a not gas is covering the world. So this is called the proper gas flow rate. We have to do in the correct sequence. Consider using a gas line instead of the standard coiled body to provide better gas shielding. So you have to always consider the instead of the coiled body, you have to use a gas line, the better gas shielding. Check all fitting and hoses for leaks. Use a gas leak detection fluid. We can use when you are starting the welding for TIG weld. You have to check that gas, what are the hoses. It should not be leaks anywhere. If there is a leak, there is a flow rate will be vary, and that type of contamination will be created. So it can be available in the most welding supplier. We can buy this detection fluid, and we can check the hose and fittings. If there is a if bubble from you have a leak, need to replace immediately to detect it to defective components. If everything else check out, you may have moisture in your tank. This does not happen often. Check your gas supply. Okay. So this is the first mistake one, the poor gas coverage with contamination. We'll go next. The mistake two. This is actually if the mistake two is the welding of aluminium with DC argon. Generally, we have to use the welding of aluminium with AC argon. So if why you are using DC, why you are using AC, what will happen with DC? See, you should generally always the TIG weld aluminium with alternative current. Always you have to use alternative current. If you are using the direct current, will make it difficult to eliminate the aluminum oxide layer. So when you are doing the aluminum welding, there will be one create the aluminum oxide layer. If it is DC welding, then it cannot be remove that oxide layer, and that oxide layer it will be melted with your original base metal, and it will be in contamination, it will be contribute to contamination. So we have to use the aluminum weld AC alternative current. The electrode positive portion of the AC cycle etches away from the oxide, while the electrode negative portion melts the base metal. So electric negative portion melts the base metal. AC balance control allows the operator to tailor that balance to the weld. So AC balance control, it is the balance control to the operator. Brown or a black oxidation or flags in the oil puddle can be eliminated with increase of AB. So we can, if it is the electrode positive, if it is increase too much, then increase then too much, then conversely balls of tungsten cause excessive etching. While the start welding, once the paddle has shiny appearance, this is how you know the oxide is removed and you are ready to the add of the filler metal. So this is the second mistake, the welding of aluminium. If you are doing the DC, we have to always use the AC current. Mistake 3. You see how it is look like the welding, the grainy aluminium weld. Grainy, what is grainy? The grainy appearance of the weld head is typically caused by welding too hot, too much, cause too much base metal dilution. So typically caused why it is appearance the grainy appearance by welding too hot, caused by welding too hot. If it is welding is too hot means amperage is a more causing too much base metal diameter. If it is dilution of the base metal is more means amperage is more, then it will come to the welding is too hot. Find that sweet spot that is not too hot or too cold, and this graininess will go away. So we have to check when you are doing welding at the weld joint area, it should not be too cold or too hot is the normal temperature. You may have the wrong type of filler metal. If it is wrong type of filler metal, then you can use the grainy appearance. Always remove all grease, oil and moisture from the filler mesh metal. So this is one of the mistakes weld graining. So you have to check the when before do the welding, it's caused by the welding too hot. If it is welding too hot, causing how it is caused welding too hot because of the dilution of the base metal. So find the sweet spot. We have to use the sweet spot that is not too hot or not too cold. We have to, when you are doing welding at that area, we have to check this should not be not too hot, not too cold. Maybe it's wrong type of filler metal use, and it should be always the, if any welding you have to, when you are doing the welding, you have to remove the all grease, oils and moisture from the filler and base metal. This is called weld graininess. Mistake 4. You see here is you can easily understand that lack of fusion in the root. In the root there is a lack of fusion. This is the mistakes 4. You see how it is create lack of fusion. Lack of fusion at the root of a T joint or a fillet weld can be caused by a number of factors. So this lack of fusion can be in the root 2 joint or fillet weld. Improper fit up, if it is fit up not proper, holding the torch too far away from the joint. If the torch is holding is too far away from the joint, then what will happen? Then the, if it is torch is too far, the melting will not be done there. So that's called lack of fusion. And improperly feeding the filler rod. If the feeding, if it is not controlled the feeding of filler rod, then you cannot melt that area. That's called the lack of fusion. Reducing arc length will provide better directional control and help increase penetration. It is also important not to underfill the joint or weld too quickly. So reducing arc length. So if it is arc length is reducing, will provide better directional control. So it will be arc length if it is reduced, then better directional control and help increase penetration. If it is done the penetration, then lack of fusion will not be created. Inverter based power should offer greater control over arc performance, allowing us to tailor the trailer the arc to be more focused into the pedal. So inverter based power source if we use, then it will be the lack of fusion can will be controlled. So this is the lack of fusion. We can naturally, if it is there is a this type of you cannot follow, then definitely there will be lack of fusion will be created. The mistake 5 you see here, the purity fluid well craters and the oil crater. So this crater, what is craters? Craters occur at the end of the weld. It's always occur at the end of the weld and lead to cracking, and it causes the cracking. Is a very this crater is a very common defect in the TIG welding. Always you can see, and if it is there, then it will lead to cracking. Causes include instantly dropping the weld forward and removing the filler rod too quickly. So if you're doing welding and if it is the weld power is suddenly low, then it can cause the craters. If it is it, and if you're doing welding, after that suddenly you are removing the filler rod quickly, then it causes the craters. Adjust your technique and continue to feed the filler rod while slowly reducing current at the end of the fill in the crater. So adjust your technique and continue to feed the filler metal. Okay, you are continue to fill the filler metal when you're drilling, and when you think that you need to finish your welding, slowly reducing the current at the end of the filler crater. So if you reduce the current of the slowly, then it will be fill in the crater, and using a TIG welder with the crater control function may also help. So this is how to you to control the crater. Dirty base metal and filler metal. All base metal and filler metal need to be clean, whether it's mill scale, oxide or aluminium, or dirt and grease. Grind, brush, and weave away all potential contamination for cleaning aluminium. Dedicated or stainless steel brush to the task to prevent contamination from other metal. Never use brake cleaner. So it's very important also for crater. We need to always filler metal we need to be clean, and there should not be any melt scale, oxide on aluminium, dart or grease. So you need to check dirty base or filament. If it is dirty base and filament, we have to clean properly. After that, we have to start the welding. So crater will not be created. So mistake 6. You see mistake 6. What is mistake 6? Is there uncleaned steel well. This is uncleaned one side, and the one side is the and that bottom side is the clean steel oil, and the upper side you see in the right hand the unclean chrome moly, and this is the clean chrome moly. So how we can detect this one and how we can prevent? All the base metal and filler metal need to be clean, whether it's mid scale, oxide on aluminium, or dart on grease. So if it is mid scale, if it is oxide on aluminium, so every all base metal and filler metal, all base and filler metal need to be clean. Grind, brush, wipe away all potential contamination. For cleaning, aluminium dedicates a stainless steel brush to the task to prevent contamination from other metal. Never use brake cleaner. So in the aluminium, when you are using the aluminium, we have to use the stainless steel brush to the task to prevent contamination with other metal. If it is use the brake cleaner with other metal, then it will be contamination with aluminium, and there will be defect will produce. So this is dirty base metal and filler metal. In what type of this is what happened? Why is created like this? This is the dirty steel weld, and because of the base metal and the filler metal, it was not clean. It was a mill scale. Mill scale. That's why it is happening like this. Mistake 7. What is this? The poor color of stainless steel and the good color of stainless steel. So how we can put poor color of stainless? The discoloration of stainless steel weld is caused by atmospheric contamination. Each color indicates the temperature of the surface of the weld when the shielding gets dissipated or was removed. So discoloration of the stainless steel weld is caused atmospheric contamination. So it depends upon totally based on the atmospheric condition. Each color each color indicates the temperature of the surface of the weld. So this color we have to how this color is changing. The you can check the different color. This means the temperature of the surface. Okay, If the weld shielding gas excessive discoloration could be caused by the overheating and could degrade the corrosion resistance and mechanical property, making the weld rejectable. So excessive discoloration means the metal will be rejected, maybe degrade the its corrosion resistance. The corrosion resistance will be degrades or mechanical property, and the only solution would be scrap the part and the start over. Okay, that part will be the scrap and then the start over the new. We have to make the new one. From there we have to cut that scrap. To prevent overheating, reduce amperage. We have to overheating. How will you prevent this? Reduce the amperage. You have to reduce. Slightly increase table speed. You have to increase the slightly table speed. Then amperage will not become. It will not become overheating the area. Or sorting the arc length. If it is sorting the arc length, pulsing also reduces heat input and it offers excellent control of the wallpaper. So if it is do pulsing, then it is also reduces the heat input. AWSD 18.2 2009 Guide to Weld Discoloration Level on Inside Ordinary Stainless Steel Tube is an excellent guide to help the determine the when the level of discoloration may or may not be acceptable. You should always refer the welding code you are using to be sure. Okay, so this is the poor color of discoloration is depend upon what is called the atmospheric contamination. If the atmospheric contamination is there, then we can see that there is so many uh, color changes because of the temperature. The poor color stainless. Mistake 8. You see, sugaring of stainless steel. Sugaring of stainless. What is sugaring? When oxidation. Oxidation occurs around the weld when it is exposed to oxygen in the air. So oxidation there is happening when you are doing the welding and the root welding. This is, you see, this is you can see this is the you can see the root welding. This is the root welding or the infrared welding. Anyway, occurs around the weld when it is exposed to oxygen in the air. So, sugaring of the stainless means this is called oxidation. Means oxygen is cage the your welding and there is a oxidation happen layer. The best way to prevent sugaring means oxidation is to ensure you have adequate gas coverage on the front and back of the weld. This is called the purging gas, and to be sure that you do not overheat the weld. So if you are doing TIG welding, that's the both area, in front and the back area. If it is the purge gas is there, means oxygen is a purge gas is there, then it cannot be oxidation cannot be occur because the oxidation and the oxygen layer it cannot be contaminated with the or melting and the base metal. So sugaring this metal, we have to purging gas. We have to check in the both area in front of the and the back of the old metal. So this is mistake 8. So I think is understanding the oxidation. Now is mistake 9. Is too much amperage in aluminum. If it is current is too much, what will happen? You see, setting the amperage too much on aluminum creates a wider profile. If it is current is too much, then weld bit will be the wider and ill-defined bead and can potentially lead to burn through. And if it is wide bead will be there and it can be potentially burn through. To solve this problem, reduce amperage and increase the table speed. So too much amperage on aluminum, this type of you can see this type of white bead will be happen and it can be burned through. And so reduce the problem. What we need to do? Reduce the amperage and the travel speed will be increased. Mistake 10. Use a figure 10. Change the arc length. If you change the arc length, then you see the various area and you have to check the there is you can see the picture how it is changing the arc length. What will happen with this welding? Proper arc length control. The color change in the middle of this aluminum weld bit can result from an increase in arc length. So when you increase the arc length, what will be the happen? Arc length is holding too long of an arc increases overall heat input. So if you do arc length, it is long, then heat input will be the more because you have to stay in that area continuously. So it increases the overall heat input and increases the potential for it can be cause the potential for distortion. If it is heat input more, it can be cause the your hardness and the material property will be changes. So it can be cause a distortion. widen the weld bit while decreasing the penetration. So if it is penetration is decreased, then weld bit will be the widened and affects weld bit appearance. So it can be old affect weld bit appearance can be affect. So practice holding a consistent arc length to move to improve heat input control and weld bit control quality. So when you are doing the WPS, there is the TIG welding, and this arc length will be there. In the arc length, this is not also non-essential, it is not essential variable, but we need to follow that arc length what you are doing in the WPS, and it is, so you have to control that arc length in the throughout in your welding. If it is arc length you are changing, that can be happen your material properties distortion. So this is proper arc length control. You have to control the proper arc length. Okay, I think this all this from 1 to 10 is a very important mistakes we have to control in TIG welding. Okay, thank you guys. I think everybody gone through for every each point. If you have any comments, just go to the my YouTube page and put there any comments and any feedback. Thanks for watching, and don't forget to share and subscribe my channel for more interesting video. Thank you guys. Bye bye.